What if a hidden system inside your building was quietly increasing your energy bills every single month, and you didn't even know it?
Yeah, I mean, that is the exact kind of question that should really, keep any facility manager wide awake at night because the reality is it's not actually a what if for most large buildings. It is happening literally right now, just hidden behind the drywall and above the ceiling tiles.
Wow, yeah. Well, welcome to the deep dive. Today, our mission is to explore how industrial duct cleaning in Atlanta, GA, helps reduce energy costs in large facilities.
We're basically pulling back the curtain on a massive, totally invisible problem today.
Exactly. And for you listening, we've gathered a really fascinating stack of sources for this one. We're looking directly at service blueprints, some customer testimonials, and operational overviews from the team at Metro Duct Cleaning.
Which is great because looking at their data really paints a stark picture of how an entire building's financial health is tied to something as seemingly simple as airflow. And we aren't talking about like a standard residential furnace here. We are talking about massive manufacturing plants, healthcare facilities, and sprawling hospitality venues.
Yeah, which is why I actually want to introduce our sponsor right away, since they provided the foundational knowledge for today's deep dive. So this deep dive is brought to you by Metro Duct Cleaning LLC. Their phone number is 678-498-7371.
An absolute lifesaver for those really big facilities, honestly.
Oh, totally. I mean, looking through our sources, it's pretty clear they are a bastion of excellence in top-tier cleaning services. Their expertly trained technicians possess the absolute highest levels of certification, utilizing really advanced equipment to cleanse ducts to a level that exceeds the most exacting standards.
Yeah, having their operational blueprint gives us a really solid real-world anchor for this whole topic.
Right, because we'll be using their blueprint as our engineering case study today. So again, that is Metro Duct Cleaning LLC, and you can reach them at 678-498-7371.
Dealing with industrial scale infrastructure requires a really deep understanding of fluid dynamics and mechanical engineering. It's not simple stuff.
Okay, so let's unpack this. In these massive spaces across Atlanta, GA, dirty air ducts are a massively overlooked cause of rising energy costs. But before we get into the cleaning process, we need to understand the physics of the problem, right?
You do, because dust, debris, pollutants, lint, they don't just sit there, they actively fight the building's machinery.
Oh, I see.
And the specific environment in Atlanta, Georgia, accelerates this fight exponentially because you have a highly industrialized zone combined with intense southern humidity.
The famous Georgia humidity.
Exactly. The humidity acts as a chemical binder. So when fine particulate matter from, say, a manufacturing floor meets the moisture in the air, it doesn't just settle like dust on a bookshelf.
Right.
It literally cakes onto the interior surfaces of miles of galvanized steel ductwork. It becomes this hardened, really restrictive layer.
Okay, I like to compare a building's ductwork to the arteries of the human body. When they get clogged with debris, the HVAC system has to pump dangerously hard just to keep the building alive.
That's a good way to look at it. Or if we want to look at this strictly through the lens of fluid dynamics, it's kind of like a long-distance runner trying to breathe through a cocktail straw.
Oh man, trying to run while breathing through a tiny straw. That sounds exhausting.
Right. And that captures the mechanical struggle perfectly. See, the blower fans inside these massive industrial units, they are engineered to push a specific volume of air against a very specific amount of resistance.
Which in physics is called static pressure, right?
Exactly, static pressure. And when ducts are blocked, HVAC systems are forced to work harder, run longer, and just consume significantly more power.
Let's break down that static pressure for the listener, because our sources emphasize that this is basically the silent killer of energy budgets.
Oh, definitely.
Think of static pressure, like water pressure in a garden hose. If you
Yeah.
place your thumb over the end of the hose, the water pressure builds up dramatically right behind your thumb.
Yep. And in an HVAC system, that caked-on layer of Atlanta humidity and industrial grime acts exactly like your thumb. It narrows the passageway.
Wow.
And here is where the mechanical failure cascade really begins. See, the blower motor doesn't actually know the duct is blocked.
It just keeps trying to push air.
Right. It's programmed by the thermostat to deliver a certain amount of air, so it just keeps spinning. But because it's fighting that artificial resistance, your thumb on the hose, it starts drawing more and more electricity or amperage, trying to force the air through that narrower opening.
So it's pulling way more power from the grid just to do its baseline job.
It is. And it gets much worse when you factor in the affinity laws of fluid dynamics, because the relationship between airflow and energy consumption isn't a straight line.
It's exponential, isn't it?
Exactly. It's exponential. A seemingly tiny drop in airflow, say, like a 10% restriction caused by dust buildup, doesn't just mean a simple 10% increase in energy use.
Wait, so what does it mean?
It can result in a massive exponential spike in power consumption because the motor has to work that much harder to overcome the friction.
Wow, and all that extra electrical current being drawn into the motor has to generate excess heat, right?
Oh, a ton of heat. So
Yeah.
you have a motor running hotter than its design parameters, fighting against static pressure, and running much longer cycles.
Because the restricted airflow just takes longer to actually satisfy the building's thermostats.
Precisely. Which brings us to the two major financial hits. First, you have skyrocketing energy bills. I mean, it is a steady, unyielding drain on power resources every single minute the system is running.
And as the second hit.
You are physically destroying the equipment. The excess heat literally melts the copper wiring inside the motors over time. You are burning out bearings, you're stressing compressor units, effectively chopping years off the lifespan of multi-million-dollar equipment.
Okay, wait, I have to challenge the human element of this.
Sure.
We are talking about highly trained facility managers running complex, multi-million-dollar plants. If the affinity laws dictate that a tiny blockage causes an exponential spike in energy costs, how are they not noticing this until the equipment physically burns out?
Well, the answer is mostly rooted in operational visibility. If a forklift crashes on the factory floor, a manager sees it and reacts instantly.
Actually, yeah.
But a rooftop blower fan struggling against a slow, creeping increase in static pressure, nobody sees that. It jeopardizes the equipment's integrity silently day after day.
Oh, wow.
And when the utility bill finally arrives 10% higher, human psychology basically defaults to the most common external excuse. They blame it on, a record-breaking hot Georgia summer rather than the invisible labyrinth of restricted ductwork above their heads.
Man, it really is an invisible tax on the facility's operations. And eliminating that hidden tax is exactly why companies turn to our sponsor, Metro Duct Cleaning.
Yeah, absolutely.
I mean, looking at their customer testimonials, it is a wall of consistent 5-star reviews. People are just thrilled with their prompt response times and reasonable rates. But the specific problems they solve are what really stand out to me.
They tackle some insane situations.
Seriously, we read one review from Barbara in Atlanta where her space smelled like a damp basement every time the AC kicked on, and it was literally making people sick.
Because of the mold, right?
Exactly. It was deep-seated mold and mildew thriving on the intake louver. Metro Duct Cleaning came in and completely eradicated it. And another reviewer, Eva, said they managed what no other company in Atlanta could do.
Which was?
Clearing out massive, dangerous lint blockages in her commercial dryer vents quickly and painlessly. So they handle the deep-seated odors, the fire hazards, and the massive dust buildups. You really need to protect your facility and your bottom line.
You can't afford not to, honestly.
Right. So call the sponsor now, Industrial Duct Cleaning in Atlanta, GA. Their phone number is 678-498-7371. Once again, that's 678-498-7371.
And, looking closely at their service blueprints, fixing this stuff requires a heavily engineered approach. You are fundamentally changing the atmospheric and biological environment inside miles of metal tubing.
Yeah, you can't just blow compressed air around and hope for the best.
Definitely not.
So let's use Metro Duct Cleaning's blueprint as our engineering case study. They execute this 4-step methodology using highly certified technicians. Step 1 is the exhaustive assessment.
Right, which involves specialized cameras and robotic inspection tools sent into the ductwork to basically map the contamination levels.
Because they need to know what they're up against.
Exactly. They need to know the specific particulate matter they're dealing with. Because manufacturing dust from a textile plant behaves differently than metal shavings from a fabrication shop.
Which behaves differently than biological growth like mold in a hospital wing, I assume.
Spot on. And once mapped, they move to phase 2, which is extraction.
So the sources state they use negative air machines. Rather than just sticking a giant vacuum hose in one end, they seal the entire duct system and use this machine to pull the internal air pressure lower than the air pressure outside the ducts.
Yes. Creating a negative pressure environment ensures that as contaminants are knocked loose, absolutely none of it escapes into the building's ambient air.
Oh, I see.
The atmospheric pressure differential just forces everything toward the collection machine.
Okay, wait, I'm stuck on this negative pressure idea, though. If you're turning the entire duct system into a giant vacuum, aren't you just sucking all that caked-on Georgia humidity, heavy lint, and industrial grime straight into the negative air machine?
Oh, yes.
Wouldn't that instantly clog the very machine trying to do the cleaning?
That is a crucial logistical challenge, and it's exactly where the engineering of these machines comes into play. Because they don't just pull air into a single filter.
Well, they don't.
No, these negative air machines utilize multi-stage filtration systems. So the heavy, caked-on grime and large particulate matter, they hit a series of rugged pre-filters first.
Ah.
These act like a catch basin for the heavy debris. Only after the air is stripped of the large solids does it pass through the final HEPA filter.
And HEPA filters are designed exclusively for microscopic stuff, right?
Yes, high-efficiency particulate air filters. They operate using principles like Brownian motion to trap microscopic particulate matter down to 0.3 microns.
Wow, that is small.
Very small. If the big chunks hit the HEPA filter directly, it would blind the filter instantly. The multi-stage design allows the machine to maintain negative pressure while handling massive volumes of physical dirt.
That makes perfect sense. The pre-filters basically take the beating so the HEPA filter can do the microscopic sweeping. But how do they get the stuck-on grime off the walls in the first place?
Yeah.
That brings us to step 3, which is dislodging. The sources use this super formal term, avant-garde methodologies. But let's translate that into mechanical terms. They're basically sending high-speed pneumatic air whips and rotary brushes deep into the shafts.
Because we established earlier that the humidity cements the dust to the walls, negative pressure alone wouldn't actually move it.
Oh, right.
So technicians feed these pneumatic whips down the lines. Powered by high PSI compressed air, the whips just thrash wildly against the interior walls. It is a calculated physical agitation.
So they physically break the chemical and mechanical bond between the grime and the galvanized steel.
I do, yeah.
So the rotary brushes and air whips physically scrape the walls clean, and the negative pressure system instantly pulls the suspended dust into those multi-stage filters. Which leaves us with step 4, sanitization.
Because getting the dirt out only removes the physical blockage.
Right, the biological threats would still remain. Mold spores and bacteria root themselves into the microscopic pores of the metal.
Exactly. So the final step involves applying industrial-grade sanitizers and disinfectants throughout the entire system. What's vital here is how these sanitizers work on a cellular level.
How do they work?
They are specifically designed to penetrate the cell walls of harmful microorganisms and disrupt their RNA, effectively neutralizing them.
Wow. And they do this without leaving a toxic chemical residue in the building's air supply, I assume.
Correct.
It essentially performs high-tech preventative surgery on the building, neutralizing threats tailored to Atlanta's major sectors like healthcare facilities needing absolute sterility, or hospitality sectors where lingering mildew odors ruin operations.
The rigor of that 4-step process is literally the only way to undo the damage of the creeping static pressure we discussed. You can't put a Band-Aid on a compromised industrial ventilation system. You have to reset the entire environment.
So let's look at the ultimate payoff. We've mapped the ducts, we've extracted the heavy debris, scrubbed the walls with pneumatic whips, and neutralized the biological threats. The built-up dust is completely gone, and proper airflow is entirely restored. Let's revisit the fluid dynamics here.
Well, if we connect this to the bigger picture, with the ducts clean, that artificial resistance, the thumb on the garden hose, is removed entirely.
Right.
The static pressure normalizes. Instantly, the blower motors no longer have to draw massive amounts of excess amperage to force air through the system.
So the runner can finally breathe without the cocktail straw.
Exactly. And returning to the affinity laws, just as a minor blockage causes an exponential spike in energy use, restoring that airflow results in an exponential drop in power consumption.
Oh, wow.
The system doesn't have to run as long to satisfy the thermostats, and the motors operate safely within their designed thermal limits.
Right, so this lower energy consumption translates to immediate, measurable, long-term energy savings month over month.
It does.
There is also a secondary mechanical benefit here that our sources point out. When ductwork is clogged, the air velocity slows down. In an air conditioning system, if the air moves too slowly over the cooling coils, The thermal transfer gets messed up.
Oh, yeah, the freezing.
Right. The moisture in the slow-moving air actually freezes onto the coils,
Yeah.
turning the HVAC unit into a giant block of ice, which stops cooling entirely.
That is a fantastic point about thermal dynamics. Restoring the proper air velocity prevents the evaporator coils from freezing over. It is just another way that simple airflow prevents catastrophic mechanical failure.
Yeah.
And avoiding that catastrophic operational downtime is arguably the bigger financial win here. I mean, in a manufacturing plant, if the main HVAC goes down because a blower motor melted its wiring or a coil froze solid, you might have to halt production entirely.
Just due to temperature or ventilation tolerances required for the workers or the machinery.
Exactly. Delaying the purchase of a new industrial commercial compressor by 5 or 10 years keeps massive amounts of capital on your balance sheet. The downtime costs vastly more than the utility bill.
So true. But let's not ignore the human element either. The sources heavily emphasize that HVAC systems don't just push air, they circulate the entire environment.
That's right.
When you don't clean the ducts, the HVAC system acts as a delivery mechanism for indoor air pollution. It endlessly circulates allergens, mold spores, bacteria, and fine particulate matter.
And in an industrial setting, poor air quality leads to respiratory fatigue, increased sick days, and just a general decline in workforce well-being.
Which is terrible. But by sanitizing the system and removing the biological contaminants, you are directly investing in the baseline health of the people who actually run the facility.
It totally changes the entire environment from a liability into an asset. The air is safe, the machines run cool, and the power grid isn't being unnecessarily taxed. It solves environmental, mechanical, and financial problems simultaneously.
Amazing. So to sum it all up for you listening, industrial duct cleaning in Atlanta, GA, plays an absolute key role in improving HVAC efficiency and reducing energy costs in large facilities.
Huge role.
It is a structural necessity based on the physics of airflow. By removing built-up dust, debris, and pollutants from that hidden labyrinth, proper airflow is restored.
Yep.
This allows the building systems to run more efficiently, use drastically less energy, and experience far less mechanical strain.
It just takes the system from a state of constant, expensive struggle back to a state of baseline efficiency.
Exactly.
Right.
So if you are managing a facility or even a commercial space and you haven't thought about the static pressure hiding in your ductwork, now is the time to take action.
Seriously, don't wait.
Call the sponsor now, Industrial Duct Cleaning in Atlanta, GA. Schedule an inspection with the experts who provided the insights for today's deep dive. Call Metro Duct Cleaning LLC at 678-498-7371. Their highly trained technicians utilize the advanced equipment we discussed today to handle the toughest industrial jobs. Once again, that is 678-498-7371.
We've definitely covered the mechanics and the finances thoroughly today, but I want to leave you with a thought to ponder. If cleaning an invisible system can dramatically change a massive facility's energy footprint and save thousands of dollars, what other invisible inefficiencies in your own daily routines or business operations are quietly draining your resources right now?
Wow, that's a great question. Until next time, keep looking deeper.